what keeps me excited is that this is such an incredible global effort. It's a new frontier. It's exciting. It's hopeful. Who knows what we will discover? We're much stronger as a globally distributed unit and collectively, coming together. There are 861 known biobanks that have been registered. Let's look at what we know or what we've already discovered, but then also compare it with here are the big challenges that humanity has. I think there are many places where we haven't necessarily started to dig in with the application in mind. What I want to do is be able to share that knowledge.
Welcome back to the Strategic Planning Room, where strategy meets purpose. We explore the minds of the world's most visionary builders, thinkers, and systems shapers. I'm your host, Amy Sabeh, and today we are stepping into a realm that is as ancient as Earth itself and as essential to our future as clean air and stable climate. We're talking about microbes, and joining us is someone who has devoted her career to understanding, preserving, and harnessing their extraordinary power. My guest today is Ginger Dosier, architect, inventor, systems builder, and one of the most forward-thinking leaders working at the intersection of biology and the built environment. Ginger has spent her life translating microbial capability into real-world solutions, from pioneering bacteria-grown structural cement, now used commercially, to building global frameworks that safeguard microbial knowledge for generations to come. She is the co-founder of the Biome Consortia Institute, a globally distributed nonprofit advancing microbial applications and stewardship across the world's biomes. Her current work includes launching the ARC Federation, a global collaborative effort connecting microbial repositories to ensure long-term access to microbial knowledge and developing breakthrough non-cold chain preservation technologies that could transform global resilience. Previously, she was the CEO and co-founder of BioCement, pioneering bacteria-grown structural cement, now in commercial use. Prior to BioCement, she was an assistant professor at the American University of Sharjah and North Carolina State University. Ginger's journey is not just scientific, it's deeply strategic, profoundly purposeful, and rooted in a belief that the smallest organisms can unlock the biggest solutions. Today, we will explore how she built a career that defies traditional boundaries, how she plans for impact on a planetary scale, and how her work is reshaping the way we think about materials, ecosystems, and the future of human civilizations. So settle in. This is a conversation about innovation, stewardship, and the power of thinking in centuries, not quarters. Ginger, welcome to the Strategic Planning Room.
Thank you.
Thank you so much for joining us.
Thank you so much for having me.
We would love to explore your career, as mentioned before. And I think the first question that comes to mind is that you've built a career at the intersection of architectural biology and planetary stewardship. What was the moment you realized microbes, not materials, would be the foundation of your life's work?
That is such an incredible question. Thank you for asking. I have a few different stories to answer on that. I think the first is that my father worked at NASA, and he was the first person to talk to me about microflora and how the astronauts, when they came back from space, they shared the same microflora. And that was just very interesting to me. But I didn't start to figure out how to translate that into building materials until much later, when I was reading a book called Biomimicry, written by Janine Benyus, and she's talking about researchers that are studying barnacles that can make adhesives that are much stronger than anything that we can make. And I really fell in love with nature and biology at that point. So when I started to have this question about, well, this cement that we use for construction, it's, 8% of global CO2 emissions are from that. And I started to think about, what in nature makes cement? And I first started diving into the marine environment. And once you start digging deeper into the marine environment, you realize that there are microbes that are part of that. So it was just this fascinating journey of my eyes opening up to this invisible force that's actually helping to control a lot of the processes that our planet depends upon.
That's phenomenal. And many people choose careers. Yours feels like an inspiration or a calling. What internal compass guided you towards solving problems at a planetary scale?
Yeah. I think when we look at cement in general, concrete's the second most consumed substance on the planet following water. So this is a very, very big supply chain, if you will, that goes into the built environment. And looking at, if we can solve how we make the materials of our world through looking at a biological lens, the impact for that is incredible. And that can really help us to advance and even develop more materials or advancements in what we consider to use in the built environment, not just what we build with, but how we make, all of the materials that surround us. So I was always driven by the impact piece. How do we make this scalable? How do we make this tie into existing supply chains, but also bringing in new supply chains to the built environment, which I think was an incredible learning that I had on that adventure.
Okay, can you tell us a little bit more details about the work you've done and how long did it take you to get there?
Yeah, so I started. I was doing an internship in New York City, and at an architecture firm, and we had a deadline for a competition, which it meant staying up all night, very late, working very hard to get this competition out the door. And so I actually slept on the floor, of this architectural office as we were getting all of these pieces together for the competition. And I guess I went and took a nap. And I had this idea of, well, what if you could grow cement? And I just wrote that down in my sketchbook. And this internship was right before I started teaching architecture at NC State. And so I knew that when I became a professor, I was going to be working on some research because I had just completed some research as part of my graduate studies. So I went to that. And fortunately, when I moved to North Carolina, I lived not too far from the library at NC State, which is open 24 hours a day. And I started diving into biomineralization, or how are shells able to form? How are coral reefs able to form? And you have books on the shelf, and then you have other books that are near the shelf. So I just started gobbling them up, and digesting them and trying to understand how does this function? What are the mechanisms of action behind this? And that's when I started to realize, there is, a symbiotic relationship with commensal microorganisms that are helping to play a role in that. So I ended up as an architecture, professor. I didn't have a lab. So what I knew that I wanted to get my hands, into this and start exploring and experimenting. And so I started a lab in my second bedroom, because why not? And I could be around it all the time. And it was fascinating because I was able to bring in, microbes from the natural environment through marine and soil, and really start to understand them, but then also start to elevate my understanding by knocking on doors of different professors at NC State who gave me a lot of direction and insight. And then also taking advantage of the fact that I could do, some additional studies in Australia. So that was the beginning, of I guess, my growth and foundation into microbes and then starting to prototype, which was something I knew how to do at that time.
And I believe you gave a talk once where you described the face baby brick that you got. That was like a turning point in your career at that point.
It was exciting because there were thousands of failures before that.
Yeah.
And it was important, I think, too, at that time that I think the hardest thing that I had to do at that moment was I knew I needed to put it through testing. So that meant destroying it.
Yeah, and what kept you going? You just mentioned there were lots of failures. What kept you going?
Yeah, I think what kept me going is I knew that this needed to be in the world. Every time I walked on campus at NC State, which is full of concrete and bricks, I would imagine, wow, what would the world look like if this were to be replaced with a biological process? And so that's really what fueled me and it excited me. And thankfully, Thomas Edison, 10,000 tries, of course, because every time you fail, you're learning something. So I knew things that would not work. And from the perspective, too, of scale, and that was a very challenging time to figure out, well, concrete and clay bricks, they're very common. So how do we make this in a way that is scalable? So, it was fun to try to solve a problem.
And you talked before about coral and how that was an inspiration for you. And one cannot help but think about pigmentation in them. So do you think that there would be colored bricks made naturally one day that would replace the need to paint?
Wow, yes. So a couple of things. I have some fun stories on this. So initially when we had started the company and I ended up taking a first order, even though there were two of us at the time there. The client wanted a particular shade of gray. And at that time, I remember thinking, wow, okay, well, this should be interesting because the BioCement is translucent. It's, it really, the material, which I have a necklace here, but the material looks like the aggregate or the sand that you use. So I ended up going to different mining companies, which they have these tailings that come from their process. And there are, hundreds of them in the U.S., or thousands of them in the U.S. But I needed to figure out what color palette could be had around in this location. And there were, many different shades of gray. And then we realized, well, we could also look at pigmenting the aggregate as well to be able to take on even more, of a color palette. And so we didn't end up using a biological process for that. We used, ingredients or supply chains that were compatible with the biological function, and then as well as the biological functions helping to stabilize that pigmentation. So there was a relationship with the biology at that point. And then, now there's so many researchers and companies that have been emerging that have been able to make pigments. And so I think it's an exciting time for, bringing that different pigmentation into the built environment, specifically paints,
right?
Which lots of toxicity there.
Yeah, absolutely. That's a phenomenal story. Do you mind if we see the part that you carry with you? So that's part of a brick that you grew from scratch?
It is. Yeah, this was around the time that we started to explore polishing.
Oh, okay.
Because before that, we were just growing pavers and using them for exterior environments. And one day, one of our colleagues bought a polisher, and he's like, "Look, it looks like marble."
It does look like marble. It's phenomenal. And if you cannot see that, it's just really phenomenal. Is there somewhere where the people can go and then look up all the kinds of bricks that you were able to create? I know you have moved on to other things, and we will talk about that. But to see, the results of all the work and all the years you spent there? Can they go somewhere and then see everything you have been able to create?
That's a really good question. I know that the BioCement website, certainly has a lot of imagery, and then a couple of TED Talks as well have some of the imagery behind that. But yeah, that would be fun to collect, what's publicly available, but then also things that have been, shared before.
Yeah,
Because we even explored glow in the dark. We explored different integrated materials that, when wet, would reveal, different colorations. So we had our exploration time, which I think was fun before we really got serious on licensing to manufacturers.
Wow, that's wonderful. And do you think that this industry is going to grow in the future?
Oh, absolutely. I think that, with statistics that we're seeing by 2050, we're going to need to, increase our amount of fresh water and materials and minerals by 50 to 500%.
Wow.
So, biology is an incredible force of energy. It does not necessarily rely on finite resources, but is more regenerative in the way that it functions. And from a fermentation perspective, we know that there are ways of adding waste materials, for example, using autotrophs, for example. So being able to leverage even waste CO2 to be able to make and manufacture the materials that our world is going to need moving forward.
Wow. And you took on a whole other challenge, which is sampling and trying to categorize and create a repository of Earth's microbial life, which, based on the statistics you've shared, only 0.001% is known to us and has been explored. How do you stay motivated when the challenge is so big to explore 99.999% of what's not known yet?
Yeah. Well, I think what keeps me excited is that this is such an incredible global effort.
Right.
It's a new frontier. It's exciting. It's hopeful. Who knows what we will discover, and who knows what our imaginations will be able to create with that knowledge. So when we started Biome Consortia, we realized, well, we're much stronger as a globally distributed unit and collectively, coming together. So there have been efforts of different organizations that are nonprofit and for-profit going out and sampling, the environment and taking, that information and putting it together in a digital and a physical way. So there are 861 known biobanks that have been registered, even though we know that there are thousands more. And as a start, it was, okay, well, let's start to look at how those organizations can be connected. Let's look at what we know or what we've already discovered, but then also compare it with, here are the big challenges that humanity has right now. So one example is mining. So being able to leverage microorganisms to help us with our mining needs, because everything humans consume is either mined or grown. So we know that we are going to be mining, in our future. And you can find, in this case in particular for biomining, you can find those microorganisms in the mining environments already, or even on e-waste. So I think there are many places where we haven't necessarily started to dig in with the application in mind. And I think that's what's really exciting and keeps me personally motivated, because what I want to do is be able to share that knowledge, with everyone, but also ways of shortcutting and cutting off some of the time that normally it would take if you were, say, I want to grow cement, for example. Where do you start?
Yeah. And I look at this from a planning perspective, where if we need to get to 50 to 5 or 500% more of the resources that humans need, there has to be a targeted growth of funding, of exploration, of many, many things to get there. But it feels like people who are interested in this field are left to themselves to do their best and try to get to those results themselves, right? While this is something that would benefit the entire human race. Would you have any thoughts or suggestions how maybe government leaders around the world could help scientists to get there faster for the sake of humanity altogether? Would it be like through more funding, more collaboration? I know you've done a lot of research in different parts of the world. You took it upon yourself to go and do all of that. But are there organizations that are for profit that might be incentivized even more to get to those results? Do you know of any?
Yeah, I would say, like, I guess looking at where we need to be for that 50 to 500%. I think that is like kind of a grounding statistic. You look at the infrastructure. Does the planet have, or I guess societies, do we have enough infrastructure to be able to take this on? So that goes to capacity. So how much fermentation do we have around the world? And fortunately, this question has been coming up quite a bit. There's an organization called BioCement that's in the United States. They work directly with the government for whether it's in energy or defense. And they recognized, well, we need to have more networked fermentation resources, specifically for piloting, because that's a very challenging place to get to. You can have bench scale technologies, but to actually get it to industry, there's this middle area, which is generally called the Valley of Death. So technology readiness level 3 to 7. And so organizations like BioCement, they really help to create the bridge in that. Certainly within the UK and within Europe, there are initiatives for, the bioeconomy, biotechnology in general. Governments are taking notice. I think a parallel that we've been interested in is like on the preservation side, because, certainly we've done a good job in humanity for preserving seeds. We know that those are related to our food source. So that's, a government effort to be able to have banks for seeds to preserve. And then now there's this global seed vault in Svalbard, Norway, which is absolutely incredible to serve as this repository or safety security box, if you will. But we don't have that for microbes. We have a lot of fragmentation infrastructurally.
Right.
And so there are, governments that are getting more interested in this, national banks. The United States is actually putting something together right now called the Living Library, which is going out and sampling our national parks, which I think is absolutely incredible. So there is, notice that the knowledge is out there. We need to learn it and preserve it. Yeah. So that's exciting times for other governments and groups and for-profits the like, whether they're pharmaceutical companies or not, to be able to get that. And then from our perspective, how is that information accessible?
Exactly. Yeah. Well, the first time I ever heard that cement can be grown from microbes was when I attended your talk at NC State a few weeks back, and I was just amazed by that. So I think that sharing that kind of innovation spirit is important. It would benefit everyone. And your work spans architecture, biotech, global collaboration, and long-term preservation. How do you strategically plan across disciplines that traditionally don't talk to each other?
That's a really good question. I guess to frame it back to maybe earlier in my career, as a faculty member, you are around different disciplines and you learn how to talk, to one another, and you start to look at where could potential collaborations come from. The students that I was teaching, we researched a lot of materials. We would bring in material scientists to reviews to get their perspectives, even psychologists, because there's a lot of psychology in the built environment. And then at BioCement, we were very active about hiring multiple disciplines to work together. And it was really fun because I think we developed our own language, like everything was bio something. But it was fun to see how, these different disciplines can come together under a shared goal. Like that mission is really the North Star, what grounds everyone together. So I think that with a shared mission, that there are more collaborations and disciplines that can come together to work on solving a very focused challenge.
Or aligning on the purpose of what you do.
That's right.
Yeah. And that remains with the leader of any organization. So you obviously did a phenomenal job. So how do you balance visionary thinking with the operational discipline required to bring microbial technologies into real world use? How do you balance that?
Another really good question. I would say that it's probably half and half for me. Like, I am comfortable in the visionary piece, but the action, taking incremental steps, measuring what matters, that's important. Coming up with a plan, being able to adjust the plan as needed, and getting more perspectives on that. All of those pieces are important. I know that as you're working with a team, you can shift like operational focus or visionary focus. But if you're just dreaming and thinking and not doing, then that's going to take more time. So I think that probably what grounds me the most is urgency.
Okay.
If these are technologies that are needed today. We've been working with different organizations around the world on glaciers, and we know that glaciers are melting quite quickly, and there are many different new organisms that have not been discovered yet. So if I think about that, wow, okay, we're losing knowledge. So how do we go faster in this? And that becomes the operational mindset to help mobilize or organize groups to go ahead and get that data, connect funding, connect, the different repositories together around that. So I think that it's an A and B back and forth, but a lot of that is, the urgency that helps to keep you on track.
That's a great answer. And the ARC Federation is an ambitious, global effort to connect microbial repositories. What strategic insights convinced you that this kind of federation was not only possible but necessary?
I think when I first started digging into, okay, how many different biobanks or strain banks or efforts to go and, unlock this 99.99%, and realizing that they're not connected efforts necessarily. So there have been different models of federation in other industries. And it was very exciting, to think about having that sovereignty, but then also being part of this federation. So the thing that keeps me motivated within the federation is that, this is something that will outlast lifetimes. This is something for way off into the future. So being able to have a federation, that the federation does not own or operate, any of this. It's really the governing consensus together. Like, what happens if you have a strain bank that loses funding and all of those samples are going to go away? Having another place for that to go. So it's really more of redundancy as well as distributed across. So, we were thinking about like, okay, well, with the Svalbard Seed Vault, for example, that's a centralized location. And what they do is they take in collections from all over the world. Well, there is that model as well. And we've started to have conversations with organizations that want to get more into that space. And then certainly there are banks that part of the federation are more active, so more application driven within that. So it's a way to make it relevant now. This knowledge has relevance for today. We have needs for all of these biological solutions today, but then also we don't know what we don't know. So instead of just collecting just the genetic information, actually preserving the cells themselves and the strains, and even as a specimen, not as a consortium, not necessarily isolated, we don't even know all the interactions between them. I mean, imagine what tools we're going to have 50 to 500 years from now. And being able to have those preserved samples, we're going to learn more than what we could have known today.
Absolutely. And when you say that you are globally distributed, how does that work? And what part of the world do you have representation with?
Yeah, so we've started small. We started in the U.S. There's certainly a lot of interest in the U.K. and Europe. So we've spent a lot of time, going around and starting to see what governments are putting money behind this, but also the entire ecosystem. So whether it's incubators, for example, that are working with young innovators to develop technologies, where these different needs are the most, like, for example, in mining. So it's been really an organic process, I would say. Some of it's intuitive, like, okay, well, we know, that the UK and Europe, like, biotechnology is very much established there, in the US as well. But then starting to span out. So South America, that's been an incredible experience recently for us. And mostly because, if you look at biodiversity, 80% of biodiversity is held by 6.4% of the global population, which is indigenous cultures. And so that, for us it's such an important piece because, you go and you talk to different indigenous communities and look at, well, there are things that can be done with those microorganisms today in cultures there. So it's not just an extractive process, if you will, which I think is something that historically we've done. Humans have done this over time. Like, we go in and extract the knowledge, but not necessarily leave that knowledge intact there. So it's been an organic process to figure out, like, not just the excitement, but where the demand is and where there's already ecosystems starting to come together. And then probably for us, what's equally as exciting is places where there's not infrastructure. So trying to help make a case for infrastructure to be there.
It's interesting. You mentioned before non-cold chain preservation in many of your talks and interventions. You mentioned that they could transform global access to microbial knowledge. What strategic challenges must be resolved to make that a reality for everyone?
Yeah, it's there aren't that many preservation technologies that we've used over time. -80 is by far one of the most common. Lyophilization is another very common. Fit for purpose is a way to govern. How viable are these? Over time. Is it 50 years, 100, 200, et cetera? So really looking at how much the energy cost is over time, how much the capex is to have available, and the skill sets around that. So we've been really interested in, we know that, and we've done some fun calculations on this, if we were to have globally distributed around the world, more of a representation closer to, let's just be a bit conservative, 50% of global biodiversity for microbial biodiversity, we can't rely on -80s. Like, we simply cannot rely on that type of preservation over time. Even now, like, they break, they need maintenance and repair. What happens in environments where you don't have stable energy or power infrastructure? So if those freezers go down and you start to have a increase of temperature, things are changing in the microbial specimens.
Right.
So, it is about access, and it is about trying to get past, the need for us attaching ourselves to equipment. So it's a fun goal. It keeps me excited every day to help to connect. Who's working on non-cold chain preservation, what technologies exist, what are the stages of implementation? Because fit for purpose testing does take a long time. I mean, we wouldn't want to put all of our cards on one bet and then 100 years later realize, that wasn't necessarily the most viable preservation. But it's really a push. It's a push to get us away from the -80 into more stable preservation that's accessible.
Okay. Let's talk about stewardship. How do you think about that, not just as a scientific responsibility, but as a moral and strategic imperative for humanity? Because obviously that's what you're doing. You're being a steward for all these wonderful things that have to happen. So how do you think about that?
I think that nature has so much. I mean, we are nature. I think the divide that has happened, of course, across, and you can look at the history of this with Descartes, we don't see ourselves as part of nature. And I think that's a big challenge, that, we have this amazing nature all around us, even that we can't see in terms of microbes. And what can we learn? So perhaps it is a bit about humility and not hubris, but it's also just the recognition that we don't know much. We really do. There's so much more to learn and explore.
Yeah.
And I think that the stewardship mentality, it builds upon itself. There's, some on the conservation side, but also more on what does it mean, to work with microorganisms? Mm-hmm. What does it mean to work with these natural processes? And, I think that another guiding force for me is that we have done an incredible job of genetic engineering. We really have. I mean, over the past 20 years in particular, we've done a lot of increased, advancements. But that's also using less than 1,000 strains out of the potential trillions. Yeah. So, why would we ignore this library that's full of information that we can't possibly know right now to be able to bring that in? And I think the stewardship position is also just a recognition that we don't know, what we don't know, but that also we can be more open to things that we can't imagine.
That's a great answer. What has been your most meaningful failure? The one that reshaped your strategy and strengthened your resolve?
Wow. Okay, that's a really good question. I think for me, in particular, that sense of urgency and the realization that this is needed today. Yeah. Sometimes that can hurt you. Oh. And I think that something that someone told me years ago. I came into this like, okay, here's the plan. We need to do, X, Y, Z to get this out there. I'm saying yes to orders, even though there are only 2 of us. And I think that was good because it forced us to build a plant to be able to do that. But someone told me once, they said, it still takes 9 months to have a baby. It doesn't matter how much money you put behind this. It still takes 9 months to have a baby. And so I think that was a big lesson for me because I wanted to go much faster than that. And recognizing that certainly there are things that you can control and things that you can't control. Mm-hmm. And, you're working in an environment where startups go through failure so much, whether it's the technology development, market readiness. I was constantly thinking about not one bad piece of BioCement, we called them bricks at the time, would ever leave the plant. And it was important because it meant, well, what does it mean to have quality control, especially in a material that you usually have to have destructive testing. So building out, non-destructive testing for that, because all of the threats are constantly around you. So I would say at times, we probably did go a little too fast, but also hustle culture and startups, that is also part and parcel, and also part of the partners that you work with, in that realm as well. But I think on the market front and, putting something out there, we definitely had much more of a conservative aspect. And I think that the failures that, we had along the way, actually came from one of our first orders. Like we had 6 weeks to be able to produce this. We had, proven the technology. We'd been able to do these different aspects at scale. And then, 6 weeks before, we were running into failure. There was something going on, and we were measuring everything that we could. And so things would come up about, well, maybe there's a change in temperature at night, or maybe that there's a contamination. Mm-hmm. And so you're starting to look everywhere, but maybe not necessarily at what the actual problem was. But again, with working with multiple perspectives and disciplines, you can get to that answer faster. And I think that, going through the failures together is what actually builds up the culture and the spirit, and that we can, do this, and we're doers that deliver, is important, on that. So, working with the team, we decided, okay, let's just focus on that first brick on a pallet that's going to go to California. Yes, we need to make thousands of them, but let's focus on the first one. And so that was the lesson I took from, going through failure is let's just take the pressure off and focus on fixing this.
But it's good that you mentioned before that same urgency that you might have looked at as a failure was the grounding factor for you that kept you going all these years. So it has two edges to it, right? So
it certainly does.
Yeah, and of course, congratulations again and again on all the amazing things you have achieved. And when you think about your legacy, what impact do you hope your work will have on future generations?
I think that the important aspect is that there's this knowledge to tap into and being able to readily access it. We've heard about the 21st century is going to be the age of biology, and I'm not really sure how that's measured. And I know that Steve Jobs said it, Craig Venter has said it. There was a lot going on in the 2000s when this first started with the Human Genome Project. But I'm looking at it from like a bioindustrial, like growing everything, like growing iPhones. So I would say for me, and I hope to be able to at least see this happen, collectively together, all of us that are working in the biological space, is what's going to be the tipping point for the bioeconomy.
We were talking before about the tipping point, and sorry, we had to take a small pause. But coming back, we were talking about the 21st century as being the age of biotech, I believe is what you said. Tell us a little bit more about that. Beyond the 21st century, what do you think is the near future of biotechnology from your perspective?
Yeah, well, certainly from a therapeutics perspective and pharmaceuticals, there's so much that we will explore within that. I lean more, I guess, on the bioindustrial side, like really pushing hard to figure out, can we leverage microbial intelligence to produce, the mineral needs that we have. And, 20% of copper is biomined today, 5% of gold. So these are really good proof points to show just the power of biology. And there are, I believe, 51 critical minerals. So that sector alone, and looking at global distribution, transportation, like it's going to start to make a lot more sense to mine in a much more local environment, in a much more distributed manner. And that's what biology is so good at, is being able to produce what's needed and where it's needed. So I do think that the era of biology, or the age of biology, depending on how it's determined, usually eras are framed by what society will imagine with them. So we won't really know. So my hope is that there are solutions and industries that we can't even imagine that will take on this knowledge. And perhaps today, what we can focus on is being able to clean our soils or increase our crop yields, our crop resistance, mining aspects, remediation, cleaning up our plastic problem, PFAS, forever chemicals. So there's so much that we know that microorganisms can do today to help, clean up things, but then also what we can't even imagine. And then how will that help to transition from a fossil fuel economy to a more regenerative economy?
Thank you. That makes sense. Given that you are a creative thinker and you have reshaped a whole industry already with building bricks from microbes, what's the boldest idea you're willing to share today, even if the world is not ready for it yet?
Oh, wow. Surprise question. I love this. Let me see. Yeah, I'm quite fascinated with the microbes of the built environment. So the microbiome. When you look at the built environment and you start to sample it, there's actually not a lot of diversity of microbes, whether it's due to the materials that we use and they're just not biocompatible, or our HVAC systems. And yet we know, and this is more and more research keeps growing in this field. We know that our microbiome, our personal microbiome, takes in the microbiome of the built environment as well. So being able to look at perhaps there are microbes that can help our health and wellness that could be added to the built environment. So I think the wild idea here is, and there are researchers that have been working on this, but what does it mean to purposefully put beneficial microbes in the built environment? And what does that mean? I mean, there are some that can clean. There are some that can reduce VOCs in the built environment. So there are many, many benefits. But I think that the idea of what does it mean to purposefully put microbes in the built environment could be really interesting to see how humanity will take that on. And of course, there's several others, like we could have self-healing paint. We could have, many different processes with crystals and minerals. I think there's a whole world of advanced optics that will come out of that.
All right, awesome. So we have a portion of this segment, a closing portion that says forecast or myth. Forecast being something that might happen, or myth it's out of the question. So I have a couple of them for you. Fun. So the answer would be, is it forecast or myth, and why in your view? 50 to 100 years ahead, microbial knowledge will play a bigger role in shaping the built environment and global resilience. Forecast or myth?
Forecast.
Thank you. And then the second part is, microbes are primarily harmful.
Myth.
Ginger Dosier, thank you so much. I appreciate your participation. Thank you for joining the Strategic Planning Room. And do you have any closing remarks you would like to share other than the questions that I have asked you today?
Well, I do want to say thank you for having me here today. And also, I guess, to leave some encouragement about, starting to open up our imaginations and with disciplines, and talking with your children and talking with your family members and community, and really starting to get more conversations around the amazing world of microbes and what they can do with us.
Amazing. Thank you. And I'm looking forward for hopefully future collaborations when we can get more microbe lovers together, maybe in a panel conversation in the near future. Thank you again for joining us.
Thank you.